Okay, today we're going to be talking about the measure of spread. So the way the data are spread out from the mean or median is important to the study of statistics. A measure of variation is a statistic that tells you how spread out your data values are. So if you have a bigger variation, that tells us that our data values are more spread out and diverse than just right around the mean or the median. Whereas if you have a small standard deviation, they're going to be really clustered around the center of your data. So meaning your mean, your median, or mode. So let's talk about measures of variation. There's 4 of them. We could use range, the greatest value minus your least value. You can use your IQR, which is your Q3 minus your Q1. You can use your variation, which we'll talk about in just a minute, and you can use your standard deviation. Standard deviation you're going to use the most. So that's pretty much what you're going to see most of. So let's talk about the variance, because variance and standard deviation go together. The variance is denoted by sigma squared. So variance is sigma squared. So it's the average of the squared differences from the mean. So that just means you take your data, subtract it from the mean, square it, and it's the average of them. And then let's talk about standard deviation. Standard deviation is denoted by just sigma. And it's the square root of the variance. So look here. So if we were to look at this, if you know that your variance is squared, the standard deviation is the square root of that. And we know when you take a square root of something that's squared, well, that cancels, and all you have left is your sigma. So that's what square root is, or that's what standard deviation is. So if you wanted to go backwards, let's say you were given your standard deviation and it asked you for your variance, you could take your standard deviation and square it, and then it would give you your standard, your variance. Okay, so that's kind of just a side note for a second. All right, so your standard deviation is one of the most common and useful measures of variation. We use it all the time. So that's why we highlighted standard deviation when you're talking about ways to measure variation. Number 4, standard deviation is the most commonly used. Okay, so just like we kind of talked about variation before, if you have a low standard deviation, it indicates that the data points, values that you have, your data set, are all clustered near the measure of central tendency. Wherever, if that's your mean, median, or mode, they're clustered around that measurement. Whereas if you have a high standard deviation, it indicates the data are spread out from the center. That's really important. If I was going to highlight anything right here, I would really highlight this because this is important. We will continue to come back to these definitions again and again throughout this unit. Okay, so let's look at an example. Let's figure out how would we calculate the standard deviation or the variance. So let's find the mean and standard deviation from the data set of the number of people getting on and off a bus for several stops. Okay, so we have our data set, and what we need to do is we need to go and plug it into our calculator. So you're going to go to your L1, and you're going to plug these data sets into your L1. Now, I'm going to see if this actually works for me because my calculator is over here. Here we go. All right, so how do you get to your L1? You go to Stat, and you see this edit right here. Go to 1, hit Enter, and now we're going to start putting in our values. So 6, Enter. I don't know if you're able to see this. Let me try again. I don't think you are. I think you're still stuck on here. Okay, let me try. I might have to stop it and try again. Okay, so I want you to plug this into your calculator. I'm going to plug it into mine. You guys know how to do this already. Go back here. Okay, so when I'm plugging this in, I have 6, 8, 7, 5, 10, 6, 9, 8, and 4. And I'm hoping you guys are all doing this as I'm doing it too. Okay, so now we're going to go to Stat again, go over to Calc and run your 1 vars. Remember, L1 is your list. You don't have a frequency list, and you're going to hit Calc. All right, I see a bunch of stuff on my screen. I see, and I'm going to write them down here for you so you can see what I see. I see that the average is 7, so your mean is 7. I'm also seeing, if you scroll to, if you look at the bottom, n is equal to 9. That means we have 9 data sets in our value. Okay, so we're looking for sigma x. Do you guys see that on your calculator? I see a whole bunch of stuff. I see a big sigma x that says 63. I see a sigma x squared that says 471. I also see on my calculator S of x is equal to 1.93, and then I see sigma x, which is equal to 1.8257, blah, blah, blah. Okay, so this is the one we're looking for standard deviation. Remember I told you standard deviation is a sigma, so this is called standard, and that's abbreviation for standard deviation. Okay, so that's what we were looking for here. So when you get standard deviation, it says find the mean and standard deviation. Well, this is what it is. Your mean is 7 and your standard deviation is 1.8. So that means it's a pretty small number, 1.8, right? So if you were to look at this as like a number plot, and let's say 7 is the middle, and you're saying that that's the middle of your data, it's saying that most of the data is going to be around the center of your 7. So this is going to be, I would say, since the standard deviation is low, the data is clustered around the mean. Because we could go and see what our median is. If you keep scrolling, what's our median here? Oh, our median is 7 too. So perfect. They're clustered around the mean or the median. Okay, so I'm sorry I couldn't show you this on the calculator, but hopefully everybody remembers since we've done this in class together. If not, help each other out so that everybody is on the same page. All right, flip over. All right, so this says a math teacher must make a recommendation for a $2,000 scholarship to a local chamber of commerce. The teacher has 2 students in mind, Alan and Brianna. The teacher decides to let their grades be a determining factor. So here are their test scores for this semester. Alan, 90, 90, 80, 100, 99, 81, 98, 82. Brianna has a 90, 90, 91, 89, 91, 89, 90, and 90. Okay, so let's figure out which student has the higher mean here. What is the higher average? So I want everybody to pause. You can pause this, and I want you to go figure out the mean, the median, and then let's talk about how we would use the measures of central tendency. So I'm going to stop this, and I'm going to make a video with the calculator because I don't think that I can switch to my screen and go back and forth. I don't think so. So anyway, I will make a video with the calculator functions, and then we'll come back and I'll do another video answering these questions.